thank you for the opportunity to present this success history from the ARSINOE project. This case focuses on the Canary Islands, where we work on climate adaptation for water security in volcanic island territories. The presentation shows how scientific modeling, digital tools, and stakeholder collaboration were combined to support better decision making. ARSINOE is a Horizon 2020 project focused on helping European regions become more climate resilient through systemic innovation and stakeholder co-creation. In the case of the Canary Island, we focus on water security in volcanic island territories, particularly in the islands of La Palma and El Hierro. Our objective was to improve climate adaptation planning by combining advanced hydrogeological modeling with ultra-high resolution climate projections. The Canary Islands are one of the most water-stressed islands region in Europe. They are volcanic islands with limited freshwater resources and a strong dependence on groundwater. At the same time, the region faces increasing pressure for tourism, agriculture, climate change, and aging infrastructure. However, the volcanic aquifers are highly complex and were poorly understood before this project. The challenge is important beyond the Canary Islands. Many islands and water-scarce regions across Europe face similar pressures. If we can improve water resilience here, the methodology can be transferred to other vulnerable territories. That is why the Canary Islands provide an excellent living laboratory for climate adaptation. One of the main achievements of ARSINOE was the development of the first detailed 3D hydrogeological models of volcanic aquifers in La Palma El Hierro. These models were developed together with IGMCSID. They provide for the first time a detailed understanding of aquifer structure and groundwater behavior in these complex volcanic systems. In parallel, we developed Sigma Canarian with FICLIMA, Climate Research Foundation, an open access climate platform for the Canary Islands. The platform provides climate projections resolution of 100 meters by 100 meters, which is extremely high for a regional climate modeling. It includes temperature, precipitation, evapotranspiration, drought index, and water balance indicator. This level of detail is essential in islands with a strong microclimate variability. This slide represents the visual identity of Sigma Canarias. It is important because the platform is not only a research result, but also an operational tool that can be accessed and used by institutions and planners. The practical usability is one of the strengths of this case study. The real innovation was not only creating these tools separately. The key achievement was integrating climate projection for climate into the hydrogeological models. This allows us to simulate how groundwater resources may evolve under different future climate scenarios. In practical terms, this gives water managers predictive capacity they didn't have before. The results are already being used in real planning processes. They support island water councils in hydrological planning and climate adaptation strategies. They also contribute directly to the implementation of EU Water Framework Directive in this outermost European region. And this is not only research, it's operational decision support. The impact of this work has been recognized internationally. The project has been highlighted by the European Commission as a EU Green Deal success story. Sigma Canarias also receives the 2026 ICE Chris Bini Award for Sustainable Water Management. And this award recognizes the platform as a strategic and replicable reference model for islands and arid regions worldwide. We learned several important lessons through this work. First, ultra-local data matters. Standard regional climate models are not enough for islands. Second, climate adaptation must integrate hydrogeology, not only climate science. Third, stakeholder involvement is essential if tools are to be used in practice. And finally, outermost regions can become testing grounds for solutions later transferred elsewhere. The legacy, the new steps, ARSINOE created a foundation, but this only the beginning. We are now scaling this approach through the Genesis project, applying digital twins, AI, and nature-based solution across Europe. This shows that the work developing the Canary Islands has long-term value and clear transfer potential. In conclusion, ARSINOE has transformed the Canary Islands into a benchmark for climate resilient water planning in island territories. It is connected science, technology, and governance in a way that produces practical value for decision makers. So thank you very much for your attention.